In this hands-on video, I will demo how to use AIFS to import training data, use RNN deep learning method to train a model. And this model can be deployed on an edge device or deployed as a cloud inference. The cloud inference will based on AIFS computing resource. And we will implement this model to predict the future temperature of a device. You can imagine this device can be engine or a pump. So we can go to AIFS portal. Before building an AI model, we need to import training data. So we can create a data set. In this hands-on, I will use AIFS sample data. There are some open data we can use. But if you want to use your own data and do the model training, of course, you can use this one, my own data, and choose the DB type. We support Influx, Postgre, MySQL, this structured data, or you can upload image or upload your CSV file to S3 or AWS3. And let me turn back here. We use AIFS sample data, and in this hands-on, we will use a building module. So the corresponding data is the Firehose device temperature. And then this device temperature can be imported to like InfluxDB, Postgre, and Mongo, or S3. If you choose S3, this data will export it as a CSV file. And in our demo, I choose to use MongoDB. And if you use MongoDB, you need to input MongoDB external URL. And let me test if it is correct. And then the collection name, if you want to avoid having some collection name, if you do some hands-on, you can change the name here. Okay, this is the setting about the dataset. And if you want to check your data, you can use, because we use MongoDB, so I will use Robo3D to check the data. And here is the data I just import. So here is the data you can check. And including the data, including the equipment of the status or the fan status and the temperature here. So this is the training data. And the next step, I will prepare the training module. AIFS provides some open source algorithm, open source module. You can do the model training. And this one, we will use RNN temperature, this module. And RNN is a kind of neural network. And this is powerful for modeling sequence data, such as time series or stock price. So we need to subscribe this one. After we subscribe, we can go to subscription under workspace. So this is the module I just subscribed. And this page will list all the module you subscribed here. And there is a icon you can check if whether this module can be editable. So the RNN temperature, we can modify the original code and modify this one to fit your own situation. To check the code, we can choose a Jupyter Lab container to view the original code. And there is a running Jupyter Lab container. I can open the code. But if you don't have any Jupyter container is running, you can go to setting or enter notebook under workspace to create a new Jupyter Lab container. And this Jupyter Lab container is provided for developers. They can do some developing process online. And if you want to create a new container, can name by your own and choose a default execution environment. And this container, you can choose what kind of image you want to use. In some case, if you are do some training like structured data, you can use pure CPU is enough. Or if you want to do some testing about image classification or object detection, maybe you will need to use GPU. So if you want to use GPU, there are some CUDA version you can choose to activate a corresponding Jupyter Lab environment. So in this case, we use CPU is enough. And since you choose a CPU image, the resource plane only available about pure CPU resource plane. So if you use a GPU version, it only available GPU resource plane you can choose. So let me go back. We use CPU for our demo. And use 2 CPU 4G memory is enough. And you can choose a default model repository. And this is in your developer process, maybe you will create a model. And this model can use AIFS model SDK to upload a certain repository. So assign a model repository can help you to upload to a certain repository. Okay, since we already have a running Jupyter Lab, we can go back subscription and check the code about RNN train. And here is the RNN temperature, the training code here. Of course, you can modify it on use Jupyter Notebook, or you can directly use this module. And since we already have the training data and the training algorithm, we can set a training task. So we will go to this batch here to create a training task. There are several steps you need to configure. The first step, you need to choose a data source, which is we create previously. And if the data, because the data is structured data, tabular data, so we can see the features, each column, each feature here. And then the second step is to choose the training module. So this is the module we need to use. And same as the model repository we mentioned on JupyterLab container, choose a default repository. And after the training task is finished, it will create a model file. And this file will upload to this default model repository. And there are some advanced setting you can set here. Here is epoch, LSTM, or loopback. These variables you can modify, and this value can affect the accuracy about this model. And this module we also provide some like model name you can modify. So maybe I can add my name about the model name. And the features corresponding to the device temperature data set, which you can look up the training data here. It will use kW fan voltage input, like this one. It will use these two features to do model training, and then predict. And the temperature output is our prediction. So like the label, we also assign in here. So if you want to apply your own data, of course, you need to import your own data first, and then change the features here. So as the label. And here is the quick setting here. Or you can, in other way, you can go back to JupyterLab and change the features level in here. Okay, so this is the setting. And the third step, to choose an environment, to choose a resource to run this training task. And the trigger is the default will be the current time. If you want to activate this training task later, you can set a later time. And the action is optional. This is for some training tasks, especially about the image task, training task. It will take a longer time, maybe 2 days or 3 days or longer. So the developers maybe want to receive a notification about the training task is succeed or failed. So you can choose if the task is succeed and failed, AIFS can send a message to tell you the result about this training task. And the notification group you can set on another service of WisePass is this notification. So you can set the notification group who you want to notify. And with this, you can send a mail to certain people. Okay, so in this case, we don't have to set the notification. So it will take a few minutes to run this training task. Okay, you can see the training task, the status is succeed. So it means the training task is finished. And in real case, maybe the status will be failed. If you face the failed status, you can see the execution here. You can see the log here. So if your job is failed, you can see the log to check the question here. And after the task is finished, it means there is a model generated. So we can go to model management. And in this place, we'll list all the model you trained on AIFS. And we trained the model called RNN model Emily, this one, and we can check because in this module, we use loss value is our indicator. So we can see the loss value. So in real case, you can define different indicator like RMSE or accuracy. You can define the indicator in your code. And if you define the code, it will show the corresponding indicator in model management. And AIFS also support the model can be downloaded. Okay, so far is the how to import training data and model training.